Many times we need to find the magnetic field due to a current carrying circuit wherein we don't have any symmetry to utilize Ampere circuitous law. So for that we will need Biot-Savart law, uh, which is a basic law. If we take it as experimentally derived law, then we don't need to do any derivation of it, and we can find other laws from this Biot-Savart's law. However, since we are taking the starting point as Maxwell's equation, so let us try to derive this law from those. So in our previous lecture where we studied this vector Poisson's equation, we saw that del square A is equal to minus mu naught J is going to give us the solution A is equal to mu naught upon 4 pi J dV dash, where this prime is always representing the source location over R. Now, for a thin wire with cross section S, I can write this dV dash, the small volume is simply S into dl dash. That is, if this is thin wire and its length is dl dash and this area is S, then this volume dv dash is simply S dl dash. So you see that now A can be written as, if I replace this dv dash here, then J dv dash is equal to J S dl dash. And since we are assuming that we are working with steady currents and the direction of dl is in the direction of the current, and this current density is perpendicular to this cross section, then I can write it as simply I dl dash. Okay. Now since the steady currents we are dealing with should flow always in closed loop, because we have seen that del dot J is equal to 0 for steady currents. So they should always form closed loops. So now I can write this A as, since we are now working with steady currents and we have converted this J in terms of IDL dash. So the total A should be found from the full circuit IDL dash, where now I will be integrating over the full circuit. Okay, that is this full wire. If I is steady, I can take it outside mu naught I over 4 pi dl dash over R. Now we can find the field B is equal to del cross A is equal to del cross mu naught I over 4 pi dl dash over R over the full curve C. Now since uh, this integral and differential can be interchanged, so I can write, if this this curve is not changing or moving, then I can write mu naught I over 4 pi over the full curve C dash del cross dl dash over R. Now we will utilize the identity del cross some scalar into vector g is equal to del f cross g plus f del cross g. Now for our case, f is equal to 1 by r and g is equal to dl dash. So del cross dl dash over r is equal to del 1 by r cross dl dash plus 1 by r del cross dl dash. Now you see that this del is with respect to unprimed coordinates, that is on the field points. However, this dl dash is at the source points, so both of are independent, so the differentiation should be equal to 0. So this is equal to 0. So now we can write b is equal to mu naught upon 4 pi I over full curve C del of 1 by r cross dl dash, and this is equal to 0, so no need to write it again. So this is b. Now we need to further simplify this del of 1 by r. Now, as I have told, what is r? If this is the source point x dash, y dash, z dash, and this is the field observation point o, x, y, z, so this is r. The magnitude is r. So r is simply x minus x dash square plus y minus y dash square plus z minus z dash square under root. So 1 by r is equal to x minus x dash square plus y minus y dash square plus z minus z dash square power minus 1 by 2. So del of 1 by r will be equal to ax dou by dou x of 1 by r plus ay dou by dou y of 1 by r plus az dou by dou z of 1 by r. So now let us solve it further. Dou by dou x of 1 by r is equal to minus 1 by r square dou by dou x of this quantity x minus x dash square plus y minus y dash square plus z minus z dash square power 1 by 2. So it will be equal to minus of x minus x dash over r cube, because r is simply this. So if I solve it further, it 1 by 2 will come here, so it will be minus 1 by r square into 1 by r into twice of x minus x dash into 1 by 2. So this will be like this. So x minus x dash by r cube. Similarly, dou by dou y of 1 by r will be equal to minus y minus y dash over r cube, and dou by dou z of 1 by r will be equal to minus z minus z dash over r cube. So you see that del of 1 by r, del of 1 by r is simply minus sign I will take common from everywhere, ax x minus x dash plus ay y minus y dash plus az z minus z dash. Now r cube is simply x minus x dash square plus y minus y dash square plus z minus z dash square raised to power 3 by 2, or it is simply minus. Now this whole quantity is simply the vector r over r cube, or I can write it as minus r ar over r cube is equal to minus ar over r square. So you see now that b is simply mu naught I over 4 pi minus where it is this is del cross dl dash by r, so it will be minus mu naught I over 4 pi over the full curve C equal to AR by R square cross dl dash. Now I will take this minus sign inside and reverse this cross product. So I will have mu naught I over 4 pi dl dash cross AR over R square, and this integral is over the whole curve, closed curve. Or I could easily write in this form, or in this form, mu naught I over 4 pi C dash dl dash cross R by R cube. So this is how we can find the magnetic field directly without calculating the vector potential using Biot-Savart law. So Biot-Savart law is very simple. Now this B can be simply written as integral of dB over the full curve C dash, where dB is equal to mu naught I over 4 pi dl dash cross AR over R square. So actually this is the form of Biot-Savart law. It is French name, so you can write spell whatever you want to spell in your accent. So we will utilize this law also for calculating the magnetic field, and we will also try to find magnetic field by calculating vector potential by solving some numerical examples in next lecture. So if you find that this lecture is helpful to you, then please share and subscribe our YouTube channel, and also join our Telegram group whose link is given in the description of this video. Thank you.